TV, and in today's video we're going to look at a question on the turning effect, or in other words, moments. Okay, without any further ado, let's look at a question which involves a turning effect. The topic, turning effect. So this question came in the November-October exams 2007, paper 1, question 7, physics, Cambridge O-level. So without any further ado, let's read the question. Okay, so the question goes like this. The diagram shows a boy of weight 500 Newton sitting on a seesaw. He sits 2.0 meters from the pivot. Okay, let's look at our boy. So our boy here sits 2.0 meters from the pivot. So the question goes on saying, what is the force needed to balance the seesaw? Okay, so we know the formula we're going to use here. The formula we're going to use here is the principle of moments, which simply states that the sum of clockwise moments is equal to the sum of anti-clockwise moments. Okay, and we know how to find moment. Moment is defined as the product of force applied and the distance from the applied force to the pivot. Okay, so that's how we define what moments. So let me just get my pen. So we're going to use the principle of moments, which we know that sum of anti-clockwise moments is equal to sum of clockwise moments. Okay, so here we're going to look at the diagram. That's where we're going to get our data. So from the diagram there, we can get what on the right hand side, that's our clockwise moment. Then on the left hand side, that's our anti-clockwise moment. And we know that moment is equals to the force times the perpendicular distance from the pivot. Okay, so here we know that let me just write the equal sign here on the middle. Then here we know that the boy is 2.0 meters from the pivot, and the force applied while the boy is sitting is 500. Let me just get my pen. 500 newtons. But on the other side of the seesaw there, let's look at the anti-clockwise side. We have applied force. We have applied force here. This one here, this is applied force, and the distance moved is is 4 meters from the pivot. Okay, so let's go back to the solving part. So there we're going to multiply F, which is the unknown force, times what? The distance from the pivot. Since we know that moment is equals to force times the perpendicular distance from the pivot. Okay, that's why we are multiplying these figures here. So when you multiply F by 4, we're going to get 4. Let me just write my 4 properly. You're going to get what? 4F is equal to, when you multiply 500 by 2, you're going to get what? 1000. Okay, what do you do to find the value of F? You simply divide 4 on both sides. So here we can divide by 4. Also here we can divide by what? By 4. Let me just move this in front for space. Okay, so that we say 4 into 4, this one cancels, this one cancels as well. I'm going to mean what? F, the missing force, or the balancing what? Force. So when you divide 1000 by 4, you're going to get what? 250 Newton as your what? As your balancing force. Let's look at the options. If you have 250 Newtons on the options. Okay, let's see. Let me just zoom it a bit. Okay, so we can see you have A, B, C, and D. And A is what? 250 Newtons, B 750 Newtons, C 1000 Newton, and D 3000 Newtons. So our answer is what? A. Okay, thank you for watching Mutare TV. I hope you have learned one or two things. Paper 2, physics questions for Cambridge O level, which is physics 5054, will be done at Mutare TV when we reach 500 subscribers. So if you want paper 2 questions to be done at Mutare TV, please share more of the video and like more of the video, and advertise for Mutare TV so that we can reach 500 subscribers, so that we can start paper 2 questions. Thank you for watching. May God bless.